I'm going to have Sewell follow me this time. Yes, sir.
I found this in my book. There's this book in this.
It might be directed to you. Okay. Let's go ahead and get started here. Hopefully you already worked these problems out, but I'm going to ask for the understanding behind it. So not just, this is the answer, great. Because today, we're going to test your knowledge, and I'm going to actually see if all of you get this as a class and as individuals in just a moment. But who knows what to do with the first problem? Okay, Drew? What do you do?
Add 6 plus 4.
Okay, why do you add 6 plus 4 to get 7 to the 10th?
I can explain this.
So I need the explanation.
They have the same base.
Okay, they have the same base, and those bases are being multiplied. So when you have two powers that are being multiplied, and they happen to have the same base, what do you do with those exponents? So listen, on your homework, you may not have done this, but you're going to do this tonight on tonight's homework. I'm going to check this as part of your answer. You need to show me that addition by saying, since these are, the same base are being multiplied, then you do 6 plus 4, which equals 7 to the 10th. So this is my answer, but I need to see that work. You're like, Mr. A, why are you making us do so much work? I'm going to tell you right now, if you don't show me that work, you're going to mess up on some things. You're like, addition? Really? Yes, addition and subtraction. And I'll prove it to you in about 10 minutes. Okay, the bottom one, 3 to the 8th divided by 3 to the 3rd. Mary, what'd you do on this one?
You're going to subtract 8 times 3.
Okay, so you get 3 to the 5th. Okay, can someone explain why we're allowed to do that? Because, just subtract things or add just because you want. There's got to be a reason behind it. Anyone? Andrew, I see that hand.
Wait.
So how can I go from here to there?
Because if you're dividing the two same, if they have both the same base number, you would just subtract the exponents.
Yes, if you're dividing two powers with the same base, you subtract the exponents, and this is your subtraction problem. 3 to the 8 minus 3 is 3 to the 5th. So how many of you got both of these correct? Okay, how many of you understand the work? I put it in quotations. I mean, really, that's work. It's not that bad. You need to do that on all the rest of your problems now. Questions before we move on? Yes, Gracie?
Okay, so how yesterday you wrote out 3 8 times, and then you did
3 times.
Yeah. When would you use that?
I wouldn't use that anymore.
Okay.
Yeah, I wouldn't use that anymore because you could do it on all these problems. You can write 3 8 times, 3 times, cancel them out, and you will get 3 to the 5th in the numerator. But you can also just do this, and you get that same answer with less work. Yes, sir. Drew?
We're learning to do it with different base numbers.
Okay, so I've been deciding how I'm going to deal with that. We're not going to go through that in our homework, but let me show you what you would do. If you had, for example, 7 to the 6th times 3 to the 8th. Okay, are they being multiplied? Yes. Do you have the same base? No. So can you just add those exponents? No. The way you would work that out, you find out what 7 to the 6 is. 7 times 7 times 7 times 7 times 7 times an extra 7. And what 3 to the 8th is. That many times. Then you have to multiply those out. We're not doing that. Okay. We'll do that next year. I'll save it for next year. All right, next problem. Next two problems here. I want you to work these out real quick. Get me your final answer, and we'll talk. These are special problems because you're going to get a special result. I want your answer to be a base to some exponent. That's what your answer needs to look like. A base with some exponent. And the exponent can be any integer, right? Integer is what we're talking about today. So go ahead and work that one out. And you can work both of these out. Two problems here. Okay. Sophie, what'd you do on this problem?
I subtracted 2 from 2.
Okay, so you did this. You kept the same base, and you have 2, the top numerator 2, minus the bottom exponent 2. And what is 2 minus 2? 0. Right? It's not It's not nothing. It's the number 0, which is an integer. Now, does anyone, this is your answer, by the way. This is your answer if you did this problem. That is good. But does anyone remember what that's worth? What is the value of this in standard form, which I'm not saying you have to do on this homework. Josiah? 1. Okay, you're like, no, that can't be true. Yes, it is true. Any number to the 0 power is always equal to 1. Like, that's a definition. And can I show you another way of looking at it? What's any number over itself going to be? Always 1. So that's 1, and that's 1, and that's 1, and they're all 1. Okay, anyway, 1. 1's important. Okay, questions. We'll go here. Gracie?
So if you did put 1 as your answer, would it be considered wrong?
No. I'll take it, but on your homework tonight, if you get this, if you get 2 minus 2 or whatever minus itself, and you get 0, you need to leave it like this. Mr. Ray, do we need to leave it like this or put 1? I answer that question. Yes, sir. William?
If we did 1 for a problem on yesterday's one.
That's okay. Yeah, I'm okay with that. But tonight's homework, I want to see that. Sam? The next one?
Yeah.
All right, go ahead and work it for me, please. What do you do on that second problem?
2 minus 4 would get you negative 2, right?
2 minus 4 would get me 4 to the negative 2. That's correct. And you can leave it just like that. 4 to the negative 2nd. Sorry, Swivel doesn't like me when I turn around. He actually starts making fun of me, and that's why he's moving around. Yes?
Last night I put both answers. I marked like 1 and 5
Sorry, this one? Yeah, that's okay. And even this one I would have accepted other answers, but tonight, what you're doing today and tonight if you have any homework, I need to see it like that. Okay, but review, what is this worth in standard form? What's that worth in standard form? Okay, Anna Grace?
-8.
Not negative. Not negative. That's the tricky part. There's a negative exponent, but it's not a negative number. Yes, Eva?
16.
Close. Ooh, you got so close. Not just 16, but...
1/16.
Yeah, it's equal to 1/16. So you don't have to circle. That's not your answer that I want to see, but it is worth 1/16. Wait, you're like, whoa, what? When you see a negative exponent, what word do you think of? Reciprocal. Everyone, when you see a negative exponent, what word do you think of? Reciprocal. Wow, no one's excited about that. You know, I'm excited about that because if I didn't think reciprocal, I'm thinking, wait, is that -16 or is that negative 16 or is that 16 to -1? I'm confused. But if I think this reciprocal, I'm good with it. Okay, so here's your second definition we looked at yesterday. Any number to some negative exponent is the reciprocal of that positive exponent. So that's the definition. Hopefully you guys know it. Man, Swivel, he needs some oil. You hear him moving around? Yeah, sorry. He never used to do that. Sorry, Swivel. No offense. Everyone okay with this? Third definition that you need to get. I'm going to go up here on this board, and you need to write this down. Any number by itself has an exponent. Does anyone know what that exponent is? It's not written there, but it could be, and it is there technically and officially and for your sake. Alex? Yeah. If you have a number just by itself, or you could say a base, it does have an exponent of 1. You could write it as an exponent of 1. Any base, just written by itself, can have an exponent of 1. Not 0, because if it has 0, what is that worth?
1.
The whole thing would be worth 1. So give me a number, Henry. Just give me a number. 3. If I wrote 3, what exponent does 3 have? What exponent does 3 have? William? 1. If 3 had an exponent of 0, would these be actually equal to one another? No, they're not equal to one another. So it does have a 1, not a 0, if it's just written by itself. All right, so keep that definition because you will use it. You probably saw it. Does anyone remember doing it in your homework last night?
Yes.
Yeah, I think it was 7. 7 to no exponent was actually 7 to the first. Okay. You guys good on that? We've got 3 definitions. We have 2 laws. And now I have 5 problems for you. Okay. Yeah, Andrew?
What count off from last night's homework? We just put 7 and not 7.
No, yeah, you're good. Last night you're good. Tonight we're going to be very technical on stuff. Okay, good questions. All right, next problem. Take a look at this. The problem is up here, not these 1, 2, 3. I'll fill that in. This is your problem. Yeah, let the jaw drop, pick it back up, adjust it, and then let's deal with it. Okay, how many of you think that's semi-complex? What's going on? I agree. It's like, ooh, you look at it, kind of like threw you back. We went from real simple problems to this kind of problem. And just like with life, guys, if something's very complex, something's very difficult, you can stare at that difficult or complex problem, let your jaw drop, never pick it up, and just, I can't do this. Can't do it. Or you could take it one step at a time. Okay, so here are my 3 steps. Mr. A's 3 steps to success in life. Okay, or at least with fractions. Yes, sir. Sam, do you want?
Sure.
Okay, hold on. Let me give the first step and then you can work it out. First step, I'm going to keep you here so. Simplify numerator. Or you could say simplify the top if you don't like numerator, but numerator you should get used to that. Or simplify the numerator. You're like, what do you mean? Look at the top. If I just gave you 11 to the 9th times 11 to the 3rd, could you work that out?
Yes.
Mm-hmm. You would do 11 to the 9 plus 3, and what does that give you? 11 to the 12th. Hey, I just simplified the numerator. Good, you just did one step. 11 to the 12th. Which I know looks kind of weird, but it is 11 to the 12th power for just the top part right there. Yes, sir?
I thought that said 11 to the A power.
Oh, okay, maybe it's this. Now it looks like a Q. I don't know what to do to make it easier, but hopefully it's a 9. Is that okay? Okay, so here I have 11 to the 12th. Second step, what do you think it might be? What's my second step? Yeah, Michelle?
Simplify denominator.
Whoa. The 3 steps to success in life are actually not that bad. Denominator. Yeah, it's simplified denominator. All right, so you're like, what do you mean simplified denominator? Well, look at the denominator, and how would I simplify 11 to the 2nd times 11 to the 5th? So how would I deal with that, Hudson?
It'll be 11 to the 2nd plus 5.
11 to the 7th. Oh, hold on. Yep. So you got 11 to the 7th. You guys okay with that? Step 2 complete. What's going on with those two?
Divide.
If I just gave you this problem, could you do it? Oh, wow. So you know what my third step is? There's no more numerator. There's no more denominator. Simplify. I'm trying to think of some other aider. I just put simplify again. Yeah, good. You a lot of good words you guys use. Fraction, expression, thingy. Just simplify. Make it even simpler. All right, here. How do I simplify this right here? Drew?
You do 12 minus 7?
11 to the 12 minus 7, which would give me
11 to the 5th power.
11 to the 5th power is your final answer. Not too bad, right? So you look at a big problem and you just get thrown back. And you could be paralyzed by that fear. You could say, I could deal with the top, I could deal with the bottom, and then I could deal with it in the last step. Here I got 11 to the 5th. Not too bad, right? You guys good on that? Not too scared? Well, you should be scared because there's another problem I'm going to give you. Okay. Use the 3 steps for success, and you can be a success yourself. Sponsored by Math and MRCA, the Eagles. Okay, next one. I'm going to have this. You guys do it by yourself. And I want, how many are there? 23 of you in this room. I need 22 of you to get it right before we move on to the next problem. So you're like, one person can get it wrong. One person.
Alright, I'll be the person to get it wrong.
Can you try?
21.
Yeah, but he doesn't have paper, he can't write.
Oh my. Okay, fine. 21. 21.
21 out of 22.
All right, so no communicating with each other. You work it on your own. When you get the right answer or you feel you have the answer, raise your hand. I'll check it. I'll say yay, that's good. Or I'll say nay, that's bad. If I say nay, you cannot redo it. So don't just guess and like, I hope this is right. Nope, it's wrong. You don't count anymore. So should you go fast on this problem?
Like 30 minutes. I have a question. Yay! I bet now all of us except for one person is going to mess up.
All right, go ahead. Work this one out on your own. And a pause swivel.
Wait, you took a one away. Is it one spare?
I didn't think you saw that. Just work it the way it is up here.
Oh, yeah.
Okay, go ahead and work it out. Once you get your final answer, please raise your hand, and then I will tell you that yay or nay. By the way, I'm going to give you a hint. Your answer should be -7 in parentheses to some power. So -7 to some power. So Mr. A, I forgot the parentheses. Nay is my answer to you. You can ask, but I won't answer necessarily. Go ahead.
So, does the 7 need a 1?
I can't answer that. Okay, continue. So if you're ready, forever hold your peace, guys. You can't. One of you can mess up. No pressure.
I guarantee I'm going to mess it up.
All right, raise your hand and I'll come by and check it. No. Nay.
Well,
There is! No!
Actually, hold on. Make sure I got this right. Did I write the correct problem? No, nay, sorry. Okay. Nay. Uh-oh. Where's your answer? Nay. Nay. Nay.
I got it. Wait, Mr.
Time out. I don't know why. I think I wrote it wrong on my paper. Now I'm looking at it. Okay. Let me look at those again. Raise your hand again, because I think I
got
I'm
it
looking at
right.
mine. It doesn't make sense. Yay.
What about me?
Nay. Nay. Yay. You don't count. That 0 goes outside.
Wait.
Yay. Nay. Uh-oh. I think I have like 6. Nay. Yay.
yay.
Nay. Yay. Nay. 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 Yay.
I got it right! Oh,
Nay.
Did you get it right? What the world?
Okay, I'm going to come by this row and then we'll see how you guys did. Sorry. I don't know. Yay. 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 All right. I'm going to give you a second chance after this. That's okay. I didn't check everyone's because some of you are like, I hope he doesn't come to me. Oh, I'll come to you on the next one. Just not this one. I'm giving you a little grace.
I want another one. What was the answer? What was the answer?
Hold on. Let's go through. Because I am going to give you one where we cannot move on until you guys, a certain number of you guys get it right. So if you didn't get it right, that's okay. We'll figure it out. All right. 3 steps. Simplify the numerators. Number 1. Is there anything to do with the numerator? No, I just leave it alone. It's already as simple as it can be. All right, the denominator, though, can't be simplified. So you're looking at this, and some of you did see I erased a 1, but it's actually still there even when I erase it. It's right here. There's a 1 right there. So what's -7 to the first times -7 to the fourth? -7 to the fifth.
I thought it was trapped.
This? Sorry, we haven't done subtraction or addition of these, so yeah, I'll make that clear. Okay, but anyway, negative 7 to the 5th over negative 7 to the 5th. What do you do with those exponents? So negative 7 to the 5 minus 5, which equals negative 7 to the 0. And did you hear what I said? Because some of you, I said nay. You're like, Mr. I got that. Okay, you got negative 7 and you got a 0, but you didn't have the parentheses. On this problem, it would be necessary because if you just put this is actually equal to negative 1. You're like, wait, how is that equal to 1 and that's equal to negative 1? Look, what's the base in this problem? What's the base? Negative 7 to the 0, 1. Anything. Yep. This one is saying the opposite of 7 to the 0. Well, what's 7 to the 0? 1. What's the opposite of that? Negative 1. They have different values. So I need those parentheses. So if you didn't do that, it's okay. I'll give you another chance. Trust me, but I won't hold back.
No, I got it right, but should I just put a parentheses on every negative?
No, parentheses when there's parentheses in the problem.
Okay.
That's the easy way to do it. Yes, sir.
Okay, so if you just wrote negative 7 in parentheses, do you have to write the 0?
Yes. If you don't write the 0, what exponent is there?
Yes, but it's in parentheses.
1.
Oh, yeah.
Yeah, so see, that changes it. So, guys, is there a difference between 0 and 1? Well, yeah. It's the difference between having a value of 1 or having a value of negative 7 or 10 or whatever. Okay. I'm all about second chances, guys. 12 of you need to get this right. Just 12. I'm knocking it back. 12. So that's a little more than half. All right. Go. 12 of you. Okay, so please, if you want, are you joining us now or what?
It's even harder now.
It is harder, but only 12 of you have to get it this time, so fewer. Okay, so these are multiplication symbols. I don't want to confuse anyone. That's a positive 5, negative 3, negative 5, positive 3. So work that one out. Be super careful. There's a reason why I'm having 12 of you do it. It's not as straightforward as you think. Show me your work and you'll do fine. You don't show me your work, good luck. And the work is simply addition, subtraction. It's not that complicated, I hope. Yes, sir. Or are you giving me the answer? I haven't.
It's a nay.
No, it's a nay. I'm sorry, it's a nay. Now I remember the answer. Okay.
Can you tell me the answer?
No.
Well, that means I got it wrong.
No.
I know the answer.
So I'm going to count who gets it. I'll count you as one or whatever. No.
Wait.
That's wrong?
Yes, that's correct. Oh, that's wrong.
Don't look at my paper.
I'm not looking. Yay, we got our first one. I have one. I need 11 more. Two. You got two here now.
I figured out what it is.
Okay.
Oh, wait.
So I can't. Okay. 3, 4, 5, 6. I need 6 more. 6 more.
Okay, I got it.
Oh, no. I'm sorry. You got to write it down, which you can't, so I understand. 7. I think I'm 7. No. 8. No. I need 4 more.
That's like 10 over 0, and that's a 1.
9. 3 more. What's your answer? Sorry.
We need 3 more.
Point to it. 10. 11.
Come on, one more person.
Wait, we have 11.
Who has an answer? Who has an answer?
Is this it? Is this where we end? One short of 12?
No, Brad hasn't answered yet. Brad hasn't answered
He did. He was the first to give me the answer. Question?
Wait, that's right, isn't it?
Yes.
No.
Are you doubting yourself? Don't doubt. Okay, I think either we've exhausted all the options or some people haven't, and that's okay. We got 11.
Just writing what Phil just telling us.
Oh, okay, gotcha. Thank you. All right, let's deal with the numerator. So 10 to the 5th times 10 to the negative 3rd is 10 to the 5 plus negative 3. And then, what is 5 plus negative 3?
2.
10 to the 2nd. So I think I saw on your papers, even if you got it wrong, you got this part right. So far, so good. The bottom, 10 to the negative 5th plus 3, which would be 10 to the negative 2nd, which again, I saw on your papers. So far, so good. This last step, you were supposed to do what with those two exponents? Subtract, but you actually added. And you didn't even know it. And the reason you didn't know it is because you didn't write it down. For most of you. Okay, what am I supposed to do with these two exponents? Subtract. So I get 10 to the 2 minus negative 2. 2 minus negative 2, right? You just subtract these two. 10 to the 4th is the answer.
Mr. A, I said Mr. A has 2 is 10.
Oh, that's okay. Disaster strikes on that one. Okay, how many of you got the 10 to the 2nd in the numerator? You got that? How many of you got the 10 to the negative 2nd in the denominator? How many of you got 10 to the 4th overall? How many of you got these first two parts but didn't get 10 to the 4th the first time? Okay, how many of you now can do this whole way through and you'll nail it?
Can we have another?
Okay. Last chance. No. I have to give you at least another problem, but I'm going to let this one go. We're going to count Philip. That's fine. All right. Next problem. 15 of you need to get it right. And if you get it right, we get it right. We go through it real quick. We're done. We can get the homework on the board. If 15 of you do not get it right, then I go through another problem, and then 15 of you have to get it right. All right. Now, I'm going to pause here. I'm going to wait. I'll just wait. So listen carefully. Look, I know I like the enthusiasm. It's cool that you want to get your... I've never seen a group so enthusiastic about getting their homework. Give me that homework. Give it to me. Okay, that's cool. That's good. But don't put too much pressure on people, because if I were in your seat and I got it wrong and you're slamming it down my throat, I feel bad. Like I know what it feels like to mess up. I mess up all the time. So don't put extra pressure. Just let it. If they get it right, great. If they get it wrong, it's okay. It happens. But you realize that I'm not going to make this easy because
It's math. Nothing's easy in math. It's math.
what a bad explanation. But I'll take it. Go ahead.
I'm not doing it.
So,
Are we allowed to use
you can use your notes. Okay, guys, I'm going to give you a helpful little hint. Yeah, you have these fractions, but are they all the same base?
Yeah.
You're just keeping the same base and doing stuff to the exponents. Don't get stressed out. Go. All right, go ahead and work. No more talking. If you talk, you don't count. So raise your hand when you're done, and then I'll get it. So you should get 3/4 to some power. And you're like, wait, but it's a fraction. Yeah, a fraction's a number, just like you've been dealing before. It's just going to be a little bit different. Okay. All right, I have my answer. Once you give me an answer, you cannot give it to me again, and I will count you yes, yay, or nay. Or I'll count. I'll count. I don't know. 1, 2. So we got 2 so far. And remember, don't put pressure on people, because that's hard. Shh. So I got 2. I think I got a 5 right now. There's one thing missing. I could give it back to you if you put that thing or things. Oh, man. 3?
Count it,
4. Oh, I can't count yours. 4. I got 4. I need 11 more. 5, 6, 7, 8, 9. Ooh, we're on a roll. 6 more. 10, I think. 11. You're close, but look at your work and you'll see. Oh, yes. 12. 13.
2 more, come on.
Now remember, guys, pressure should be minimized. Don't put pressure on them.
Bill got it.
That's hard. Yeah. 14.
I don't want to be a part of it.
Okay, sorry. I'm nervous for you guys because I want you to get it. 15. Okay, so good job, guys. If you didn't get it or you haven't gotten there yet, so you got a wrong answer, or you're still working through it. All right, I'll wait for you guys. I just got to work this one out. The next screen is the homework. Okay. I got to keep waiting. Okay, you guys ready? Same bases are being multiplied. What do I do with those exponents? Just add them. 3 plus negative 9, which is... Okay, so I have 3 to the negative 6, and then this one already simplified. Okay, this right here we said was negative 6. All right, so here's my problem. Most of you got to this point. But you have to subtract. So you do 3/4 to the negative 6 minus negative 4. You got to subtract. Negative 6 minus negative 4 would change, opposite. What's that?
Negative 2.
Yeah, it equals 3/4 to the negative second. If you didn't have parentheses, it's wrong. Because you need it.
I just forgot to do the negative.
Oh, yes, that's right.
I added. Wait, do we have to do this problem right there?
Huh?
Oh, wait, never mind.
Yeah, this is the same one. All right, here's your homework.
Or would have if it counted.
Goodbye, Swivel.